Hello students, welcome to my first video lecture on signals and system. There are many books available on the internet, but here are two of my personal recommendations. In this lecture, we will cover some part of the first module, which is Introduction to Signals and System, which include basics of signals like analog, digital, continuous, discrete signal, definition, examples and their comparisons. So let's start. Module 1, Introduction to Signals and Systems, Part 1. So depending upon which property of the signals we are looking in, signals can be of different types, and one signal can have many properties. Like we can divide a group of people into two parts, men and women, or into people who are above 30 years old and less than 30. We can divide the same group into two groups depending on which part of the country they are from, northern or southern. Likewise, we can divide signals into different groups depending upon one property that we are currently looking into. And one signal can have more than one property. So, here we have divided the signals into continuous time signal and discrete time signal. In continuous time signal, we are taking the value for every instant of time. The time is on the x-axis. In discrete time signal, we are taking the value for the y-axis after a certain interval in x-axis, say 2 seconds or 2 milliseconds. So for example, suppose you are going from Kolkata to Darjeeling by bus. Now you have turned on continuous location sharing via GPS. So I can see where you are at every instant of time. So I haven't missed your location for one moment on the map of West Bengal. This is called continuous time signal. Your location respect to time has a continuous flow. Now suppose instead of sharing your location continuously with me, you are calling me after every 15 minutes and telling me your location. And on the map of West Bengal, I am putting a dot on the location every time you are telling me your location. When you reach Darjeeling from Kolkata, I connect those dots by straight line, and now I have approximate path of your journey, which may not be exact because in between those 15 minutes, you could have taken a circular path, and I would not have known it because I have connected the dots with straight line. So now this is what we call discrete time signal. Note the use of parentheses for continuous time signals and square brackets for discrete time signals. Analog signals are those whose y value can take any value, and digital signals are those whose y value can take only a finite numbers of values. Here both pictures on the left side are analog signals. On the right side, both pictures are digital. Both pictures on the above are continuous and both pictures on the below are discrete. Sometimes students confuse discrete with digital and continuous with analog. So I have given the image here. Here are some examples of analog signals. Human voice is analog because its intensity and frequency can have any range within human capability. Human ear can recognize any frequency between 20 Hz and 20 kHz. AM radio and FM radio can attain any frequency value within their limits. Temperature reading on a thermometer can have any reading within its range. So all these are examples of analog signals. Examples of digital signals are all the signals in phone and computer because any computing machine needs digits to calculate. Signals they transmit, store are also digital. Data on VCD, DVD, memory card, external hard drive are all digital in nature. Both these analog and digital signals have pros and cons. While for audio and video, analog signals are best suited. Also, they consume less bandwidth. We see them everywhere throughout the world and they are less susceptible to noise. But digital signals are needed by computer to calculate, compress and encrypt. Equipments that deals with digital signals are common and less expensive and they can provide better clarity. So students, that's it for today. See you next time. Stay home, stay safe. Goodbye.